All right. Good evening, everyone. Thank you for coming out to our final symposium tonight.
My name is Rohan Mathur.
I'm Vivian Mo.
I'm Kavanayan Kumar.
And I'm Jonathan Vielstich, and our project was exploring methods to develop cross-platform mobile apps. So to just briefly go over what we'll be talking about tonight, we're going to start out with the background on the different apps we developed. We'll start out with the native application, which we developed for Android, and we'll talk about a web application, and then finally we'll spend a bit of time on hybrid applications. And we're going to spend a bit more time on those because they're a bit newer and most likely you're most unfamiliar with those. Then we'll go through the procedure that went into developing each of those apps and then testing the apps after that. So that's going to be a bit more interesting. We'll go into our results and we'll talk about the data we gathered from that. And we'll into our conclusions where we'll analyze all of that and determine whether or not hybrid applications are a viable way to develop cross-platform apps. So just some background on smartphone technology and apps in general. Apps first became truly popular in 2008 with the release of the iOS App Store following the release of the iPhone in 2007. But now more recently there's been a bit of a conundrum as to which platform developers should build apps for. You can build Android apps that will run on Android, you can build iPhone apps that will run on iPhones, but iPhone apps cannot run on Android. So developers have to decide how they want to develop their apps so they can get to the most possible people. And that's where these hybrid applications come in. So there's actually those three different ways to develop apps that we talked about already: native, web, and hybrid.
So going to the first method, that's native application development. It really yields the most polished off application at the end, and that's really because for two factors. Firstly, it is the fastest at loading and also performance-wise in the application itself. And that's because the operating system itself is the one that is doing all the hard work of processing the application. And secondly, the aesthetics of the native application is better than any other method of developing if you just do the bare minimum. And this is because it uses a lot of the operating system resources, like the button images or the text and input images, versus a hybrid app that you have to actually package in the images that you want to use in your application into the user interface itself. And also you get to use the official platform development tools. So for example, Android has an IDE, which is an integrated development environment, and that's called Android Studio. And you get to use that, and it has a lot of different support mechanisms through both online and books and resources like that. And you can also, they're also very well developed, so they have lots of different features. But there is also a lot of drawbacks in doing all native application development. And then the biggest drawback is that it's very time consuming to develop these different native apps. And this is because you have to learn both the APIs, which is the application program interfaces, and the SDK for the software development kit for all the different platforms. And you may think, oh, I can just learn the APIs and SDK for one platform and that'll translate across multiple platforms. That's not necessarily true. In many cases, the SDK, API, and even the development environments are different across multiple platforms. And the languages themselves are different that are used to create the application. So Android uses Java, iOS uses Objective-C, and Windows Phone 8 uses C++. And these APIs are different, like I said before. So you can see here that Android has something called a toast notification. That's at the bottom there. But if you learn a toast notification on Android, you can't carry over that knowledge to iOS because nothing exists like that.
So the next method we have is web applications. These are easy to develop and deploy. They're easy to develop because they use simplistic programming languages such as HTML, JavaScript, and CSS. And when we talk about TouchDevelop, you'll see that it's even easier now. And since it runs the web browser, it's very easy to share with other people because you just send them a link to a URL address. The problem with web applications is that they're very limited. First of all, they're very slow, both at running and to actually open it, because you have to open your web browser and then type in the URL. Also, they have a very limited feature set because it runs in the web browser and can't access the internal data as well as a native app can.
So the final app is the hybrid application, otherwise known as a cross-platform app. So the hybrid application leverages both the positives and negatives of the native app and the web app. So first, it's really easy to develop, primarily because it uses web languages. Second of all, there's negative because in order to get more advanced features, you're going to have to interact with the respective platform's container code. You have access to most of the device's specific features and sensors, and the speed is comparable to that of a native application. So in our research, our main goal is to find out the efficiency of all these platforms, and we do this by testing apps across all three platforms. However, there are many apps on the market today, so it would be unfair if we just tested some apps, but left some apps out, and that would leave a hole in our research. So what we did was we came up with a list of features or tasks that many apps in the market today use. And we compiled all these features into a test app, which we wrote in all three platforms. We wrote the native app through Android, the hybrid app through PhoneGap, and the web app through TouchDevelop. And as I mentioned before, these features were tested for the efficiency, as well as their advantages, disadvantages, and their limitations.
So to go through the 6 tasks and features we determined would be best to test, we came up with an audio player, a camera, accessing a website, accessing mobile devices contacts, a video player, and then finally processing speed. Now we chose these features because they interact with what the phone is most essentially about. We have an audio player and a video player to see whether or not these hybrid applications can access media files within the phone and actually then play them at a decent quality. We have a camera to see whether or not these hybrid and web applications can use the cameras, which are very important considering the higher quality cameras that are being integrated into smartphones. We have accessing a website to test one of the most essential features, whether or not the app can access the internet. Now, we chose accessing mobile devices contacts because we needed to test whether or not the application can interact with the internal data of the phone. Now, normally this is when reserved for native applications, so we needed to see whether or not hybrid apps had this capability. And then finally, we chose a test for processing speed to see how fast this app could actually perform.
The way we tested processing speed was we had 2 randomly generated integers, and we multiplied them by 1,000,000 times. And the time that took the platform to do this was the number that we took for processing speed.
So first we went to go develop the native application for Android. The SDK and the documentation for the APIs available in the Android platform is all available at developer.android.com. And that came to be a very good resource for us, especially those of us who had never programmed in Android or at all in Java before. And applications for Android, like I said, are programmed in Java primarily, but they also use a language called XML, which is Extensible Markup Language. And that's used to create the layouts of the application itself. So for example, where you put the button is all translatable into the XML code. The applications themselves can either be tested within an emulator that comes free with the SDK, or you could actually test on a real Android device that you have, like we did. On the left, you can see a picture of our native application that prompts the user with the different tasks that we selected. On the right, you can see the audio player. On the left, you can see it's accessing a website, and that's entirely within the application itself. That's using something called a web view in Android. So it's not opening up an external browser. That's, again, entirely within the application. On the right, you can see it's accessing my contacts. On the left, you can see it's actually playing a trailer for the movie Pacific Rim. And that's, again, right off the SD card within the application. And on the right, you can see it's displaying the processing speed information in milliseconds.
So for our web application, we use something called TouchDevelop. This is developed by Microsoft, and it attempts to make programming accessible to the average smartphone user. So using these pre-programmed functions that are available as clickable buttons in the main development window, it can transfer the task of developing an app from computer to smartphone. So TouchDevelop runs right in your browser, and after your code is done, you can store it as a script, which is stored in the cloud, and you can access it using a Google, Microsoft, or Facebook account. So on the left, you can see these are the pre-programmed function buttons, and these are the only options you have, which makes it much easier because you don't have to know the API, but it's also very limiting because you're limited to these options. Also, TouchDevelop doesn't really have a user interface. When you run the script, it just comes up with this asking permission to run the app. And this is our web browsing app, which will just open up the GSet page in another Safari window. Okay, once again, we have our camera app, the main development window, and not really the user interface.
Alright, so this is our code for the processing speed for TouchDevelop. At first you can see it takes the time from the computer. It does a million iterations of randomly generated numbers multiplied by each other, and then takes the time at the end and then subtracts a second, so you get the actual seconds time. And on the right is a snapshot of that. So in this instance, it took 7 seconds. And this flow of logic was mirrored in every other platform. So in native, in web, and hybrid, we all had the same flow of logic. And it was not just for processing speed, but for all the tasks. We tried to make the flow of logic in the code the same in order to remove variation and make sure that our conclusions were based off all objective. So PhoneGap. So PhoneGap build service allows you to build a cross-platform app without having to download an SDK or any new software. So it does this by accessing your code from either Adobe or something called GitHub. So GitHub is a website where you can store your files in something called a repository, which is similar to a folder. So once you store your files in a repository, the PhoneGap build service accesses the files and you're able to run the app. So the code is written in HTML, JavaScript, and CSS. HTML is kind of like the body, JavaScript is kind of like the logic, and CSS is more of like the formatting. So the code is then injected into a container for different platforms during build time. So you can think of the code as like kind of like a little box, and you can think of the containers as bigger boxes. So during build time, depending on what platform you want, you basically keep your code in your different boxes or different platforms. So this way you can go for either for like iOS, Android, or Windows. So this is like the true definition of going cross-platform. So this is a snapshot of the GitHub website which we use to store the files. On the left, you can see the main menu for the PhoneGap app. Compared to the native app, it's not as aesthetically pleasing. In fact, before this, it was actually just hyperlinks, and we had to use some CSS formatting in order to make it look more professional. And on the right, you have the audio player. On the left, you have it accessing a website, and on the right is the contacts. On the left, once again, you have the video player. Compared to the native application, you can see that it's not as polished. And on the right, you have it running the processing speed.
So when a developer wants to make an app, he has to consider the time commitment, and we represent this using the lines of code. So you can see for the native Android app, we use a little over 4,500 lines of code. The hybrid app was a little under 1,000. The web app used 18 lines of code. The reason for this big difference is because the native app is written in Java. It's much more customizable, and Java is a very wordy language compared to the others. And the web app only had 18 lines of code because, as you remember, they were pre-programmed functions. So there was more code behind what you saw, but that's a trade secret for Microsoft.
And here you can see a graph of the processing speed versus the development method. You can see the web application took the longest to do the processing speed task and took almost 7 seconds. Whereas the native and hybrid app are much shorter. The native app took around 1.5 seconds, and the hybrid app took around a third of a second. So the web application is pretty expected as a result that it would be that high because, like we said before, the web applications are typically the slowest. But the native application and the hybrid application's results were kind of surprising. And this can be attributed primarily to the way that the application itself was executed. So the hybrid application was, so PhoneGap is basically built that the code that you put into the PhoneGap application would be executed in a minimalistic type browser. And this browser is optimized for multi-core usage. Whereas the application that we wrote, the native application for Android, it's not optimized currently for multi-core usage. So the native application was only using one core, so that's why it was taking so long, whereas the hybrid application was using all 4 cores, and therefore it could do the processing speed task much quicker. In general, the hybrid application works just as well as the native application in terms of functionality. We could do everything that we wanted with the hybrid application that we could with the native application. It might have taken a little bit more research in terms of finding out what the APIs were because they weren't as readily accessible, but you could still do them. And the native application in general, like I said before, it had a better, like aesthetically pleasing user interface, whereas compared to the hybrid application or the web application.
So TouchDevelop was able to access the camera, get a number for processing speed, and deliver and access a website in a limited capacity, as you saw. And you might have noticed that we didn't show any screenshots of media files or contact access, and that is because TouchDevelop is still in the early stages of development itself. And right now, it only offers those features for Windows Phone and Windows 8, which we did not have access to.
So improvements for our research. First, as Rohan mentioned, we would like to test out the native application and the hybrid application with the same number of threads in order to confirm which platform really runs faster. The second improvement is to test other hybrid platforms. So PhoneGap is widely regarded as one of the best cross-platform development platforms to use. However, there are others such as SensuTouch or Intel XDK, and by testing them, we'd like to see if the wide array of cross-platform development platforms are really on the same playing field. The third one is, we only tested 6 tasks due to the time limit on this project, but now that you have games and other apps that use a lot of animation, we like to test animation as one of the tasks that these apps run. And the final one, as Vivian mentioned, we like to use a Windows Phone to really test out the full capabilities of TouchDevelop. We couldn't test out the media files or the contacts, so having an actual Windows Phone would actually help us test that.
First, we'd like to acknowledge for their help our mentor, Dr. Vinod Ganapathy, and his graduate student, Dr. Kim. And throughout the entire project, they really helped guide our research. They helped us achieve our goals and also offer technical expertise.
We'd also like to thank our resident teaching assistant, Neha Desai, for continued support throughout the project. We definitely could not have done it without her.
Thank you also to the Director of New Jersey Governor School of Engineering and Technology, Eileen Rosen, and the Assistant Director, John Patrick Antoine.
And finally, we would like to thank the sponsors of the New Jersey Governor School of Engineering and Technology, without whom this program would have been impossible.
We'd also like to acknowledge the following people for their contribution through open source software: Sonia Rohe, Android developer team, and the PhoneGap team.
Here you can download both our native application and our PhoneGap application if you scan this QR code with your QR code reader on your cell phone. Unfortunately, we cannot offer the application, the PhoneGap application for iOS because we lack the signature key that you need to sign your application for iOS. But you can attain one if you pay $100 every year.
Any questions or comments?
First question is currently on this app, what's the roughly percentage of the native and the HTML5 kind of? So most of the app now still in the like Java application HTML kind of, or native kind of. I mean, currently on the market.
So there's lots of actually big name applications use the hybrid development platform currently. I'm not sure if you're familiar with the website called Imager. It's a famous website for image sharing. They actually use a cross-platform type of setup. I think they use PhoneGap actually, and that shows how powerful these hybrid application platforms are. And actually, Facebook for Android uses an HTML5 and CSS layout. They don't use an actual cross-platform type of container that's available freely, but they have developed their own, and that's what they use across their Android and Windows Phone. For iOS, they have developed their native application, unfortunately.
Another question for this native kind of approach application, if user kind of download, the user need to know what's the platform or what's the hardware the user is using in order to choose the right app?
Yeah, so like in order to learn any native app, each native app or each native platform is really different. For example, Objective-C or Java, there are different syntaxes. So in order to really get an app across multiple platforms and to use native, you would have to learn each platform, each syntax basically. But using a cross-platform app, you'd be able to just write it in HTML, CSS, and JavaScript, and then you can just import it into all the platforms. So in a way, finding out which platform to use would be based off whether you want your app on many platforms or whether you're just trying to get it on just one platform. So for example, let's say a developer wants to just write an app for iOS. Then in that case, then using a hybrid app, hybrid platform would be kind of would be worse because you're just going for one platform. So then you would just go for the native platform. But let's say a developer wants to write an app and have it across multiple platforms. Then the hybrid app would be the best choice.
And definitely, if you develop one application the native way, then you can, if you want to develop another one the native way as well, because you see the performance benefits or whatever you see as a positive in the native application development, then you can take that same logic, like we said, and use that same logic across to the next platform. It's not like you're writing a brand new app. You still have the same logic processes. So that should help you create a native app also, if you don't want to use a hybrid application development framework. All right, thank you for your time.
Thank you.